Raise your hand if you think kites and trapezoids are related.
No.
Okay, they sort of are because they both have 4 sides. But that's the only thing they have in common. Otherwise, kites and trapezoids are completely different things other than the fact that they both have 4 sides. Okay, trapezoid. The definition of a trapezoid is that you have one pair of sides that's parallel. Okay? The next property we need to learn about trapezoids is that same side interior angles add up to 180. So if this line is parallel and this line is parallel, then we have a set of same side interior angles here and here, and we have a set of same side interior angles here and here. Okay? I might actually put numbers in them in a minute, but I'm just going to write down that property first. So the property that you need to make sure you remember is that the same side interior angles are supplementary. What does the word supplementary mean again? They add up to 180 degrees. Okay, so what if I put little numbers in the corners so we can kind of use it as an example? Okay, so I've now numbered the corners. Where'd my... Let's see. Who am I going to pass this to? Joe. Sorry. Joe, you can leave it on the floor for now, but it's yours. Okay. Joe, tell me 2 angles that add up to 180 in this picture. Okay, we're just looking at the trapezoid. And I numbered the angles 1, 2, 3, 4. So tell me 2 of those angles that'll add up to 180. 1 and 4 is correct. Throw the ball to someone that needs to pay attention.
I'm paying attention.
That works. Spencer, tell me 2 other angles that add up to 180 in this picture.
2 and 3.
2 and 3. Good job. You get it? Okay, next property. Now we're going to jump down and talk about the isosceles trapezoid. How is an isosceles trapezoid different than just a regular trapezoid?
All sides are different. No,
These 2 sides are the same. These 2 sides are not. The ones that are parallel are different lengths. The ones that are not parallel are the same length. It's kind of like you take an isosceles triangle and cut off the top. We're not ready to pass it yet. So whenever we're ready, then you'll get to choose someone to pass it to. Okay. In an isosceles triangle, the 2 sides are congruent, but what else is congruent in an isosceles triangle? The 2 angles are congruent, correct? So if an isosceles trapezoid is just an isosceles triangle with the top cut off, doesn't that mean that these angles are still going to be congruent?
Yes.
Yes, they are. So the first property we're going to write down is that the base angles are congruent. Now there are 2 sets of base angles. There's a set of base angles here and here. But remember how we just got done saying that these 2 angles add up to 180 and these 2 angles add up to 180, right? So if these angles are congruent and these add up to 180 and these add up to 180, doesn't that mean that these 2 angles also have to be congruent? Yep, it is. It's something we could write down and prove, but we just kind of logically thought through it. So if you want to, you might want to say that there's 2 pairs of those that are congruent. There's not just the bottom base angles, there's also these are also called base angles. Okay? The other property you need to know for isosceles trapezoids that's not true for regular trapezoids is that the diagonals are congruent. What other shape did we learn about where the diagonals were congruent? There was one other thing we learned last time that had congruent diagonals. Which one was it? We learned rectangle, rhombus, and then a square is also a rectangle and a rhombus. Which one did we learn? Rectangle or rhombus that has congruent diagonals? A rectangle, okay? But an isosceles trapezoid also has congruent diagonals. So what if you have a shape with congruent diagonals? Do you automatically know that it's a rectangle? No, because it could be a trapezoid. Do you automatically know that it's a trapezoid? No, because it could be a rectangle. So both of those shapes, even though they're not related, have that same property. The difference is one's a parallelogram, all the sides are congruent, or all the sides are parallel, I mean. The other is a trapezoid where only two of the sides are parallel. So a distinguishing characteristic even though they have that property in common. Okay, last thing we're going to do is just go through a few examples. Try and make this quick on your own paper. And then I'll give you some time to work. I'd really like you to try and use your time wisely in class today to try and get your assignment as done as possible before you leave. Okay. Please no talking right now. You're just going to delay us. Here we go. Number 1. Here's some examples. What shape is this looking like? It looks like a trapezoid so far, right? Only I've put it sideways. Now what kind of trapezoid does it look like? Now what have I done to it? It's now an isosceles trapezoid, right? What did I do to make it an isosceles trapezoid? I put, okay, the arrows were parallel. That made it trapezoid. The other little lines tell me that the other sides are congruent, which makes it isosceles. Good. Okay, so then what if this angle here is 62 degrees? I want you to help me find angle 1 and angle 2. So now Joe's going to pass the ball to someone. So everybody be thinking about angle 1 and angle 2, because somebody's going to get the ball and is going to have to answer this question. Jose's had a turn, a big turn, so we'll let someone else do it. We'll call that, well, Brenda had a turn too. Should we say Alejandra's? Or Gloria? Oh, Gloria, okay. Gloria's got the ball, whether she picks it up or not. Here we go. Here, I'll let you do the easier one of the two. What is angle 2 going to be if this angle is 62? 62, good job. Why is angle 2 going to be 62? Because the base angles are congruent. Good job. Good job. Okay, Gloria, who are you throwing the ball to? Oh, Brenda already kind of helped me with something earlier, so give it to Alejandra or pass it to another part of the room. Okay. Alejandra, how do we find angle 1? Notice how this angle is acute. Is that angle acute, or is it a bigger angle than that? It's obtuse, correct? What? It is bigger. How do we find what it's going to be, though? Can everyone be quiet so I can hear her, please? We just talked about something about these angles. They're called same-side interior angles because these lines are parallel and they are inside the parallel lines on the same side of this transversal. Okay? So what did we just say about same-side interior angles? It is ringing. I'm ignoring it. It's Alejandra's turn. You can have people help you. Okay, these two angles will add up to 180. So how can we find angle 1? Okay, so then what will that number be? 118. Good job. So what if I put a 3 right here? What would angle 3 be? Everybody all together on the count of 3. 1, 2, 3. 118. Nice job. Okay, let's look at a different problem. Let's look at a kite. Okay, what markings tell me that this is a kite? The little congruent sides. Consecutive sides are congruent, right? Okay, this angle here is 48 degrees. I want to find angle 1 and angle 2. And then maybe we'll also find angle 3. I'll put that there. Okay, so let's see. Alejandra, pass the ball to another part of the room, or up to Eli, or back to Austin. Austin needs to wake up, so. Okay, Eli, how do we find angle 1? Angle Y is 90 because the diagonals are perpendicular. Nice job, Jacob. Okay, and Eli. Okay, pass the ball. Jacob, you want the next one? Yeah, or no? Okay, Oliver. Oliver, angle 2. Good job. Angle 2 is 48 because kites are what? Kites are symmetric, which makes it congruent on both sides. Good. Okay. Oliver, throw it back to Austin. Do you think you can handle angle 3? Okay. Tell me about angle 3. Uh-huh. Okay, so we have 180, and one of the angles was 90, so now we have 90, so then we take 48 from that. $42? Nice job. So angle 3 is 42. Okay, now all together I want you to, as I point to angles, tell me what they are. What's this one here going to be? 42. Good. What about this one? Guess what? Kites aren't symmetric that direction. We do not know what that angle is, and there's no way to figure it out. Stop whistling. What about this angle? 90. What about this angle? What about this angle? We don't know. What about this angle? We don't know. What about this one? We don't know. Do you get the idea? Symmetric this direction, but not this direction. So be careful of that. Okay. Here, let's do this one really fast. If you guys stop whistling, I will stop after this problem. If you don't stop whistling, I'll keep going. This is an isosceles trapezoid. Apparently someone who's whistling wants me to continue doing examples till the cows come home. Just kidding.
Are they good?
Okay, you guys, this is an isosceles triangle. So let's find the lengths of all the sides and the height of this isosceles, not triangle, but trapezoid. Shall we?